Okay. So example number 1 based on importance sampling. So let us consider, let's say we have this integration from 1 to 2 with 1 upon root 2 pi, which is a standard normal, into exponential of minus x square upon 2 d of x. Okay. So first part you have to estimate f, sorry, estimate I, I've assumed it is I, estimate I using basic Monte Carlo method, use n is, let's say, 10,000. Also find the estimated standard error. So we are interested to also obtain the standard error for this. So obviously to obtain the standard error, we require the mean of this. Okay, this is the first part. Second part, find an analytical expression for the standard error of your estimate in 1 and compared to the estimated standard error. Okay, so whatever you are going to obtain, you have to just compare with their standard error. And third one, estimate I using importance sampling, and take here. So now here we are defining this importance sampling. What would be the Q you're considering? So Q is nothing but Q to be Q will be the normal with 1.5. Let me say it is V square with V is equal to 0.1, V is equal to 1, and V is equal to 10. So I'm considering the different standard variance. If it is 0.1, what happened? If it is 1, if it is larger, then what happened? Okay, and just computing their value. So compute the true value, you can say. Compute true standard error in each case And also, if you want, you can draw the histogram. Also, plot a histogram of the values you are averaging to see if there are any extreme values. Okay. So maybe you can skip this plot part, because plot part is might be you make it, but let's try, just try for at least the remaining part. Okay. So I guess this first two part you can do it. First two part are very easy. We have already seen how to generate the observations uh, for let x will be greater than 4 and all. So you can very easy to estimate this I using a Monte Carlo method. You will generate the 10,000 observation from the uniform. Okay. And you may just obtain the probability between this 1 to 2, and you can get very easy that probability. Okay. And you can, based on that, you can get the estimate also. Right? Now here, if you just look at, we are here, the basically we are interested for the properties of your estimate. What are the standard error? Okay. We are interested to get for standard error in the case one, because that means we are interested to check their properties, and we have to compare to estimated standard error, and whatever estimate value we got it, we compare with this first value. Okay. And then you can use the importance sampling, and you can uh, taking the different values of variances, you can just compare their standard error in each cases. So let us see how this thing work in actual R code, because if you manually, it is not possible to compute these integration values, because you have to use standard normal table and all. Okay. So there will be no such a derivation uh, or you may say mathematical expression in this scenario, but little you can do it in the case of important sampling, but still in important sampling you will be not get much stuff. Okay. So let's see how it works in Art Studio, so that there would be some clarity in Art Studio also. Okay. So first part is that let us take the usual expressions. Okay. So here we are interested to obtain the probability between 1 is less than x less than 2 when x follows normal with 0 comma 1. So this is, we have already done for at least one problem, so you know how we can write the code for this. Suppose and you are generating 10,000 observations, correct? X are normal distribution, R norm. So that is your n comma 0 comma 1, correct? And then you are obtaining this probability, that is your length, which x will be greater than 1, and is it and operation, or you can use this and just do it. Just we have use this and, because we have two conditions, right? When x will be less than 2, and this whole thing length divided by, so whatever length we will be getting, that divided by And this bracket is not required actually. This is 1, this will be choice divided by n. This will give you the probability values, and you can obtain the probability, simulated probability. So this you can just look at. So this would be your answer, 0.1138. Okay. This is a simulated probability. Means using basic Monte Carlo technique, you can generate 10,000 observations, and that is your 0.11. You can look at the actual probability. So actual answer is, so this is something like your f of 2 minus f of n, right? How we get the CDF? This is something like probability between 0 and the 2 and 1. Nah? So f of 2, sorry, 1 and 2. So we are getting f of 2 minus f of n. So just find out CDF, that is your p norm at 2 lesser than 2 minus p norm lesser than 1. So 1 comma 0. This answer should match with your answer, but since you're simulated, so slightly difference will be there, obvious. So look at the answers, but the almost matching. Okay, almost matching. So this is your first part to solution, first question. So this is your analytical expressions of your estimates, and this we compared with our this particular estimate. So first two-part solution is this, right? Now we have to just compare with the you may say since we are interested on their properties, we are interested to get their standard error also, because we have estimated these values. Now after estimating these values, so what would be the standard error? Okay, so basically we are looking their properties of estimator. So for this, what you can do, you can find out mean, you can find out their variance using the simulation. So let's generate, let's copy this here, 10,000 observation generating. You are generating this estimate empty, and now you're using a simulation for I in 1 to let's generate 10,000 under this loop. And you are estimating just estimating the mean of this, mean of your probability values and variance of your probability values. So this you're obtaining at each every point I, shading simulation from 1 to 1000. Length will be this. Okay, so look at this expression, how it works. So we are generating 10,000 observation under this empty vector. We are storing them under this empty vector, and we are simulating from 1 to 10,000 observations, generating from normal distribution 0, 1, and every time you're estimating this probability value, which length will be this, okay, means using your between 0 and 1, between 0 and 1, it will just find how many observations there. We will calculate the probability value and it will store in this PR, and whatever that value will be there, it will have to find out the mean of, okay, variance of that estimates. So, and these answers we have already obtained. This is your actual answers, so we can compare their answers also, and we can obtain their MSc. MSc will be equal to, or will be assignment, sum of your PR value minus answer value whole cap square, whole thing divided by 10,000 observations, or we have taken 1,000 observations. So this will give you the mean square error. Just a second. Okay, let's just check with this first. So see, these are the two values you have generated. So this is your mean, this is your variance, right? Look at the actual value. Actual value is also almost matching here, whereas the previous it was 3.8 and here 5.9. So slightly different, but here it is approximate 5.8 and 5.9. Means almost it is matching. Okay. So this is the way you can generate the mean and variance. Now look at the variance also. Variance is also tending to 0 as my n is large. As my n is large. Right? Just a second here. I think okay, let's look at this MSc also. Yes, you can close it so that we'll get the answers here. So this is your mean square error. Okay, and one can get a relative error also. So it is MSc divided by your answer, actual value, mu value. So this will give you the relative error. This is your mean squared error. Okay, get this answer. So almost this error are tending to 0 as n tending to infinity. Suppose I've generated 10,000, you can generate 1 lakh observations. And now you can do the simulation. See, approximate, you will get the estimated value is same as your true value. Look at this. It will take time because it is simulating 1 lakh time, generating from n. Okay. And under that, it is simulating 100 time processes, 1,000 times doing the process and calculating the P of I. Now calculate the mean and variance. Little system will be slowly. Now look at here. Okay, this is tending to 0 and this is 0.588. This was their actual value. Point. So very close, very close, right? This is your again 0, 10 raised to minus 7. And this is again 10 raised to 6. So approximate getting 0 almost. Fine. So in this way, you can just check their standard error and square error under this condition. Okay, so there is the last part is remaining, then we will stop here. Next part is the important sampling here, which is actually our part. Okay. So let us consider first part, v is equal to 0.1. Okay, and we have defined here, let's say g, which is basically, you may call, this is some function p of x upon q of x. Okay, because just for notations I'm simplifying, because otherwise it's going to be difficult. And also I'm defining here my e of x, which is your h of x into that expected value now you obtain. So h of x into g you can consider, and h of x into g, because now my g is nothing but p of x upon g of x. Okay, we can say, we can consider x also here, no problem. H of x, this is your g of x, but make sure under we are considering the q, under the expected under q. Okay, so this is your, this part is your importance part, importance part. Okay? So again we will just obtain the estimate value. We will create, because here also we need to create a loop. So we need to create the estimate value under x is generating from what is that, x is generating, estimated value will be generating between this. So whatever probability you're generating between this, else probability becomes 0. Correct? Means what exactly we want, that is important. Okay, so my task is to be here to generate the observation between this. So what I have to do here, we create this estimate and now we create the loop. So for, let's say you are simulating I in, let's say 1 to 1000, just a second students. So we are generating the 10,000 or 1,000 observation. So we are creating a loop here, right? So for I is running from 1 to 1,000, and now here I'm defining this particular function. Now the function will be the approximate same function, which is this one. Okay, this slightly change in this case. Now what will the change here? What will change here? Can anyone suggest? We are generating from the normal. So R norm with means with n would be same, comma 1.5, because you have given q, q ka distribution is given. It is normal with mean 1.5 and variance is 0.1, which we have already written here, right? So you can take 0.1, which is, you can consider v directly, that is also fine. Okay, and then we are defining this g. That's it. Okay, what is G now? G will be look at this. If else, if you use the function here, if else x will be greater than 1 and x will be less than 2, then it will generate the observation from denom given denom, okay, denom with what parameter to specify? So it's x comma 0 comma 1, and here denom with parameter x comma 1.5 comma v, else it will be the 0. And it will estimate this I value, it will estimate this I value which is stored, and this is your mean of G. You have generated from the G, right? And we have to close this, and then you can obtain the mean of your estimate. That is your estimate value, and you can obtain the variance of this estimate value. Answers you already knowing. You can calculate MSE, which is again the same sum of estimate value minus answer cap square, that means square, divided by 1000. 1000 means your actual value. This must be the answer. Let's see whether it works or not. So this is the finally when you have the importance sampling, which is with normally distributed. So we can define Q cut distribution here. So Q follows normal with 1.5 comma V square, right? V cap 2 can write. So V is varying here. Each time the V is varying, we have to compute their mean, we have to compute their variance, have to compare their standard error also. So let's see whether it works. So the first is V. So we will be creating a loop. So if you just observe, we are generating from your Q, right? Because we are generating from the Q. Q is your important sampling. So the distribution of Q is 1.5. And then you are generating the from this G of X. So under this G of X function, this condition, if this condition true, then you are generating from these observations from this distribution, else it is 0, because we are not interested for the rest part of it. And estimating, each estimate value will be stored in this estimate value of I, which is the mean of this, and we have to obtain this mean of this estimate and variance of this estimate. Let's see its works. It will take a little time because they are doing this calculation like division of two normal and all, checking the conditions, doing 1000 times, and even n is very large. No, n is also we have considered very large. Sorry, we should take little lesser, because otherwise here it is taking so much time. We should take we should take less first, then we can increase the size amount. So now we can estimate these values. That was your answers. Now look at the exactly same, even it is good estimator as compared to this. Variance is tending to 0, mean square error is almost 0, almost 0. This is the case when you are considering V is equal to 0.1. Okay. You can consider same expression. You can do it for 1 and you can run once again. Okay, let me consider this is A1. Okay, so we can use in this way. This is the two values. Just on this. This is when you are assuming the your variance is 1. Huh? It will take a little time. And when you consider variance is 10, then what will be the result? This is your A2, right? And the answer, this is the variance again tending to very tending to 0. Right? So if the V is this, V is 10, then what happened? Now variance is large, so it is taking a little time. Now we'll compute this. So here, if you just observe this standard error, just look at this thing, answers for standard error. So this one is 10 raised to minus 9. This is 10 raised to minus 8. And this is 10 raised to minus 6. Fine, no problem. You can just go through this code once again. Okay. And out of these three, when you consider different variances, then like which estimator is better between out of these three, you can just uh, try to understand using this particular code. Okay, and tell me the next class which one is better. So this is like we have used here important sampling, but there is no derivations part. Okay, there is no derivations part here expecting. So just